Welcome to this explainer. Okay, so we live in a wonderfully messy, deeply interconnected world. But how do we actually make sense of it all? Well, before we get into the heavy theory, let me ask you a quick question. How do you think a 1950s mission to simply cure malaria ended up with the government literally parachuting live cats into the jungles of Borneo? I know, it sounds entirely made up, but I promise you, it is a very real and very wild piece of history.
Right, let's dive into this. Picture this. It's the 1950s, and the World Health Organization looks at the island of Borneo and sees a massive, urgent problem: malaria. Now, the solution seemed incredibly straightforward. They had a target, which was the mosquitoes carrying the disease, and they had a tool, a new pesticide called DDT. If you just look at that problem in a straight line, it makes sense. Spray the DDT, kill the bugs, stop the malaria. Simple, right? But they completely ignored the complex, interconnected system they were stepping into, and the results were absolutely disastrous.
This is essentially the textbook example of what happens when we ignore the big picture. Let's walk through this crazy domino effect. Step 1. They sprayed the DDT, which, to be fair, successfully killed the mosquitoes. But step 2, it also killed off a specific species of wasp. Now, those wasps naturally controlled a local population of caterpillars. So without the wasps around, the caterpillars multiplied like crazy and literally ate the thatch roofs of the villagers' homes, causing them to collapse. But wait, it gets worse. Step 3, the DDT affected other insects, which were then eaten by local geckos. The geckos could actually tolerate the toxin, but in step 4, the village cats ate those highly toxic geckos, and the cats died off en masse. Step 5. Without cats around to hunt, the island's rat population absolutely exploded, devouring grain stores and causing a huge surge in the plague. And finally, step 6, the completely absurd outcome. To fix the plague they caused by trying to fix the malaria, authorities actually had to parachute crates of live cats back into Borneo just to eat the rats.
Which brings us perfectly to our first major concept, Section 1, the unintended consequences trap, and why linear thinking fails.
Now you might be thinking, okay, raining cats in the 50s is a quirky story, but this exact same trap causes massive catastrophes today. Just look at the 2008 global financial crisis. It started with what seemed like really isolated, localized decisions in the U.S. housing market. Lenders were confidently handing out subprime mortgages because of previous economic growth and some pretty lax regulations. The linear thinking was basically, hey, we lend more money, we make more profit. But they totally ignored the vast interconnected web of global finance. So when homeowners couldn't repay and house prices tanked, it didn't just hurt a few lenders. It stressed the entire U.S. financial system, which immediately cascaded to foreign banks, ultimately crashing the global economy and bringing down massive titans like Lehman Brothers. Treating a messy web of cause and effect as an isolated linear problem, it's almost guaranteed to create completely new disasters.
So, if we want to avoid these kinds of disasters, we really need to understand what we're actually dealing with. Let's move to Section 2. What is a system? Seeing the bigger picture.
The real magic here is right in the definition itself. A system is a set of interacting or connected parts that is organized in such a way that it achieves something, a function or a purpose. The key takeaway: a system is not just a pile of its individual parts. It's the unique product of how those parts interact with each other. I mean, you wouldn't try to understand how a car drives just by staring at a spark plug, right? Just like you can't understand an entire organization simply by looking at a flat org chart. Now, every system out there shares a few key properties that make it tick. First up, we've got boundaries. Think of these as the boxes we put things in. They define the scope of what we're actually looking at. Where we choose to draw that boundary dictates what's considered inside or outside our focus. Second, we have hierarchies. This is how smaller subsystems nest neatly inside larger systems, which helps us spot patterns. And third, interconnectivities. These are the in-between spaces, the links, the causal relationships, the flows of information. These are usually the hardest things to see, but they are exactly where those sneaky unintended consequences, like our parachuting cats, are born. And hey, don't forget, you aren't just watching this from the outside. You are an active part of dozens of overlapping human systems right now.
Now that we know what a system actually is, how do theorists categorize them? Let's check out Section 3, the 4 system types, categorizing our world.
Theorists basically divide our entire world into these 4 fundamental buckets. Let's run through this table really quick. Up at the top, we have natural systems, like a biological organism. Your own body is a perfect example of this. Next, we have designed physical systems, like a skyscraper or your home. Then there are designed abstract systems, which are things like mathematical equations or calculus. And finally, at the bottom, we have human activity systems, like a team collaborating on a project or an entire massive business organization. But here is where it gets super interesting. Those first three systems, you can mostly describe them objectively. But human activity systems are a whole different beast. They are uniquely subjective. Because they involve human actors, they're understood completely differently by everyone involved, based on their own personal perceptions and beliefs. And honestly, as long as a person's understanding is logically consistent to them, it's a valid perspective. That means there's literally no single right or wrong way to understand a human activity system, and definitely no single correct way to draw its boundaries. This deep subjectivity is exactly why managing teams and running organizations is so incredibly tough.
Because these human systems are just so messy, we desperately need practical tools to make sense of them without forcing some artificial linear order onto them right out of the gate. That brings us to Section 4, Visualizing with Systems Maps, Tools to Untangle Complexity.
Let's look at the classic iceberg diagram. It is a fantastic metaphor for systems thinking. When a problem pops up in your organization, what you see at the top, the tip of the iceberg, are just the events. It's what just happened. But if you stop there, you're just constantly reacting. To really fix things, we have to look beneath the surface. Right below those events, we find patterns of behavior, the stuff that continues to happen over time. Below that are the systemic structures, the rules, resources, and policies actually keeping those patterns in place. And right down at the very bottom, the foundation of the whole thing are our mental models, the hidden assumptions, beliefs, and values that created those structures in the first place.
Another really great visual tool is the bubble map. See those blob lines on the left? They represent boundaries. Remember earlier when we said drawing a boundary decides what's in and what's out? Well, naming your main system and drawing that blob literally forces you to define your scope. Then, on the right, you start drawing smaller blobs inside to represent your subsystems. And inevitably, you'll find that these blobs overlap. Those overlapping sections instantly reveal the interconnectivities and hidden relationships you'd totally miss if you were just staring at a standard org chart.
Now, when we need to map out cause and effect, we use causal loop diagrams. This is the exact procedure we use to track down those sneaky, unintended consequences. Step 1, you just write down your variables and draw arrows between them to show how one influences another. Step 2, you label those influences. Are they proportional, meaning if A goes up, B goes up? Or are they inverse, where if A goes up, B goes down? Step 3 is absolutely crucial. You mark time delays with parallel lines across the arrows. Time delays are exactly why systems trick us. The consequences of our actions often don't show up until way later. And finally, step 4, by counting those inverse relationships, you can figure out if your feedback loop is a balancing loop that stabilizes things or a snowballing loop that is just spiraling totally out of control.
Okay, all this mapping, boundary drawing, and looking under the iceberg, it all builds up to one ultimate goal. Let's move to our final section, Section 5, Finding Your Leverage Points, Maximum Impact with Minimum Effort.
This is the holy grail of systems thinking. Leverage points are the places in a system where we can exert the absolute least effort for the greatest possible impact. Think about it. If you push against a massive boulder in the wrong spot, you're just going to exhaust yourself and it won't even budge. But if you find the exact right pivot point, a tiny amount of pressure can move a mountain. By understanding the deep structures and feedback loops through our maps, we can stop fighting the symptoms at the top of the iceberg. Instead, we find those critical nodes where a small, well-placed shift changes the entire architecture for the better.
Our source material drops this incredibly powerful insight. We can change how we see systems and our place in them by changing our boundaries and our perspective. Basically, your vantage point completely dictates the possibilities you're even able to see. If you're totally stuck on a problem, zooming in or zooming out to redraw your boundaries might suddenly reveal a brilliant leverage point that was completely invisible to you just moments before.
So, as we wrap up this explainer, I want to leave you with a bit of a challenge. Think about a really messy, complex problem you're dealing with right now, maybe at work or even in your community. Stop just looking at the events on the surface. Take a minute to dig into your own iceberg. What are the underlying structures and hidden mental models driving those events? Map it out, change your perspective, and ask yourself, where are the hidden leverage points for real change in your organization? Thanks so much for joining me, and happy mapping.